Now this is being last video I am going to upload on YouTube for your NSEM examination from my side. If you want any question, then you can send me, I can solve it, and then I will send you answer of this, or if required, I can upload it on YouTube, but will be tomorrow. So now we will go to some questions. Now I already mentioned that 5 question paper I have considered over here, and I have taken question from these question papers. Now other welded plate girder, we have similar type of question. We need not require to put the same questions. We only values are changing, and for that one it is not required to upload video again. Same case for gantry girder also need not required to upload same questions over there. Already 3 questions are there over here. Then trusses, already you are too good in trusses, you are in position to find this. But I always say, if question is design forces, then avoid it and go for gantry girder. Because in design means you have to find first dead load, then live load, then wind load, then combination of these, then forces in the members, and then you have to go design. So it becomes a little bit lengthy. Then also you can see your expertise is in which topic, and accordingly you can decide this. So now we are with questions, different questions you can see over here. Design a laterally unsupported effective span. So just I mentioned this. So we have this as revision lecture 8. So we have revision lecture 8. Similar question. So I am not going to solve it again. Then question 5, which was again May 18, sorry. So May 18, and then we have similar question. If we will go, we have this is a revision lecture 3. And therefore I am not going to put again, the only values are changed, span are changed. So need not require to repeat the questions. Now explain modes of failures. Then we have actually shear failure, then flexural failure, torsional buckling failure. So likewise, we have to explain this. Now I am going for this. So these are factorial moment. If not mentioned, then you have to multiply it by 1.5. So now someone have called, actually I don't remember his name. And his question was, sir, how we will go for check for buckling and check for clipping, or checks in this one. So now when you have a question like this, then you cannot take no deflection check. No deflection check is possible, because loading we do not know. But we can go for web buckling and web crippling. Here not asked, so I will not go over here. But web buckling and web crippling possible. Now, how it is possible? So now this factorial shear force, this will be considered as a reaction. And then you have to go with this. Now I will just draw the diagram. I will not solve actually for these two, because again it becomes lengthy. So now you have like this. And then you have this as base. And then this will be only on one side. So this already we know, we have somewhere here. And this value we will get this as, this is B. So we have this as B plus 2.5 into thickness of flange plus root radius. So you can go to web buckling and then you will come to know. So this will be this height, if you will see, then you have this will be TF plus R1. And horizontal becomes 2.5 because we have slope as 2.5. And if we will go for web buckling, then you have this web buckling that is at center. So we have that is at center. And then you have this dispersion, you have to take at center. So now in this, you have this as B. Then this distance you will get B plus D by 2. Because angle we have 45 degrees. And we have overall depth D, so it becomes half of this. So we have this P plus D by 2. That is my width. Remaining process is same. Only if you have concentrated load, it becomes B plus D. So here it becomes b plus d by 2. And then you have to solve it. You can go to web buckling video. Web buckling, web crippling. If you are not going to find it, then just message me on my number. I am again mention my WhatsApp number for any doubt. You can ask question 70388 31674. I am in the college from 8:15, but in senior as a senior supervisor, that is till 10 to 12:30. If you have any doubt, you can call me. Then I will come outside and then I can clear your doubt. Then now we will start with this question. Now, why I have taken this question? Now that again I actually forgot to explain. Whenever your shear force is larger, much larger, I can say, you can see your bending moment is 120 and your shear force is 200. That means it is very clear that your value of VD, 0.6 VD, is less than V. And then if you will go higher section and try to make this 0.6 VD greater than V, then you can lose your marks, because when higher section is not required, then you cannot go for this. Their expectation, you have to use value of MD, that we will see, that is according to clause number 9.2, and therefore that you have to use. So whenever shear force is large, then you can go a little bit higher section, but not much higher. Now we will go for this. So we have actually step 1. So given data. Given data. So we have VU 200 kilonewton, and then MU 120 kilonewton meter. Now you can see span is mentioned over here. We need not require to worry of this because beam is laterally supported. So we need not require to worry about this span. Then we have step 2, ZP required. Step 2, section modulus required. Section modulus required. Then we have ZP required equal to MU upon MU into gamma MU upon Fy. So 120 into 10 raised to 6 into 1.1 upon 250. And we have required value 554.32 into 10 raised to 3 millimeter cube. No, sorry. Required value is 528 into 10 raised to 3 millimeter cube. Now you have one section which is ISLB 300, that is at 369.684 meters. And if you will go to this, then you have ZPZ equal to 554.32 into 10 raised to 3 millimeter cube. Do not go too close. I just mentioned, because when MU is lesser one, VU is greater one, then if we have reduction in the value, we have, if you see the formula, we have MD minus beta in bracket MD minus MFD, and some value that is going to reduce. I have calculated actually this value I have, and then I come to know this value comes something 124 or somewhat like this, and that is less than, that comes 118 point something likewise, and that comes less than 120. So you can check it. I have this value actually for 300. So I have 125.98 minus 0.27 into 125.98 minus 91.72, and it is less than 120. Therefore, we have to revise section. I will not go in detail. So keep in mind, do not very close. 28 and 54 is actually close, and when we have this we use more, then we should not go for this. And therefore, I go select section, and then I have considered section as ISLB 350 at 386.63 Newton per meter. And ZPZ we have 622.95. In between, we do not have any section of ISLB or MB, and therefore we have to go for this. Do not use ISHB or ISWB for this. So into 10 raised to 3 millimeter cube. And TW also we require, which is 7.2 millimeters. And then just I have mentioned this formula. So we have to go one by one. I will first go. Now you have to go step 4. Classification that is required. You have to keep in mind you have marks for it. I am not going for this. Classification. And then we have step 5. Moment of resistance. Step 5. Moment of resistance. And then we have this MD because we have to calculate MD also. So we have MD is equal to beta B ZP Fy upon gamma M. Actually, this is step 6. We have to go for step 5, shear capacity. Shear capacity. And then we have VD equal to FYW upon root 3 gamma MW into DTW. So 250 upon root 3 into 1.25 into we have this value D we have 350 and TW 7.2 and it comes 330.66. And if you calculate 0.6 VD, it comes 0.6 into 330.66. And this value comes 198.4 kilometer, which is less than 200 kilonewton. Therefore, for moment of resistance, we have to use clause number 9.2. And therefore, formula I already mentioned, then I will put it 1 into ZPZ, we have 622.95 into 10 raised to 3 into 250 upon 1.1. And that comes 141.58 into 10 raised to 6 Newton millimeters, which is 141.58 kilonewton meter. Then we have ZFD. Now again I will say you another formula for this. So you can have for this ZPZ minus D into TW into D by 4. So now how actually it comes? You have this as web. And we are deducting this of web. So what we will get it as D by 2 into TW. And it will act at center, which will be D by 4. So we have to subtract of this web. So we will get of flange. So little bit difference you will get, but that doesn't matter. And then you can have 2 times because we are on both sides. 2 times D by 2 into TW into D by 4. And then you can have this as D into TW into D by 4. Otherwise, I already explained of flange also you can go for this. And that flange you have BF into TF into D by 2 minus TF by 2. And this will be twice. So you can go anyway. You will get same answers. Little bit difference you will get. That will be okay. Then we have this value if we will calculate. So this is 622.9 into 10 raised to 3 minus 350 into 7.8 into, sorry, 7.2 into 350 by 4, and this value comes 402.5 into 10 raised to 3 millimeter cube. And then if you will find MFD, then you will have this as beta B ZP ZFD into Fy. And then we have this as 402.5 into 10 raised to 3 multiplied by 250. And we will get this value, that is 402.5 to the power 3 into 250. So this comes 100.63. So we have just a minute. MFD, sorry, upon 1.1. So upon 1.1. And then we will get this value, because I got another answer, 91.48 kilonewton meter. 1.48 kilonewton meter. And then we have beta, that is 2 into VU upon VD minus 1 whole square. Now we have to calculate VD of this, and we have 330.66 VD value. And then we will put over here 2 into 200 upon 330.66 minus 1 whole square, and we have this value 0.044. And from this we will get MD is equal to, already we have written formula, MD minus beta into MD minus MFT. And if we will put the values, so we have this as 141.58. I am putting it directly in kilonewton meter. 141.58 minus 91.47, and this comes 139.38 kilonewton meter, which is greater than 120 kilonewton meter. And likewise, we have to solve the problems, and then we are in position to get the marks of this. So this is all about your end sem revision lectures. All the best. Study well. Do not go for any copies with you. So now we will stop here only. Thank you.